Good morning, Theo.
Good morning, Drew.
How are you doing?
I'm putting on my headset. Can you hear me?
Yeah.
Okay, good.
So are you coming to the OCP Global Summit?
I am not this year.
Oh, bummer. Okay.
Yeah, I know. I should have planned on it, but being new here, I had a few things going on, so.
I hear you. No, I totally get it. Good to see you, that's all.
Yeah, thank you. Good to see you
Um,
too.
yeah. So it would be fun, but
Yeah.
we'll have a pretty good crowd there.
Yeah, I know. I'm kind of jealous. I was talking to Yogesh. She said he's going. Um, and a number of people I know are going also. So
Now,
I know it's gonna be fun.
where are you based? You're in the Portland area?
Yeah. I'm in Oregon.
Yeah, so it'll be a little bit of a trip for you.
Yeah. Oh, it's not too bad. An hour and a half flight. It's
Yeah.
actually an easy one. Are you flying yourself there?
Yeah,
Of
yeah.
course.
Well, I mean, it's my commute.
Oh, that's right. Yeah.
So basically, I can come and go, but I got a hotel because really the value of going is all the networking.
Exactly. Yeah.
And so I like to stay at night and have dinner with people uh and
Yeah.
your guest will plan a we'll have a your guest usually plans a get together one night of all the fault management people, so that's a lot of fun.
Yeah. Yeah. Nice. See, I'm jealous. I'll catch you next year.
Yeah, next year is the answer.
Yeah.
So hi folks, we're talking about OCP.
Yeah, hey Drew.
Hey Evan, are you going to be able to make it this year?
Yep, I'll be there all week.
Oh, awesome. Okay, good. Well, then we'll need to spend some time talking.
Yeah, yeah, definitely.
That'll be
Yeah, I was
awesome.
talking with some coworkers today. I think I'm the only one from our group that's coming this year, but we got to get some more people down next year if we can. It's too much fun.
And now that we've got the document published, and we need to like start working on getting the data logged and sent to you. And I think, I'm hoping that exciting things happen.
Yeah, yeah, me too. I'm optimistic. Got to do a little bit of marketing at this point.
Yeah, me
Start
too.
talking to people about it.
Well, and like I've seen things from you and from Roy and a few things from Samsung that all indicate that the stuff that's happening, like the data that we collected for DDR4 and the improvements that you all made are making a really big difference.
Yeah,
And I don't know if you're seeing it quite as, but to me, it's like stark, uh, that it really helps to have the data.
yeah,
So, um, maybe we can, promote that and we need to work with Intel and AMD and others to uh, start collecting the data that we're said we want in the dot and see what happens. Yeah.
yeah, most definitely.
So welcome, folks. I think is Zoom HM Workstreams. Is that Yogesh?
Yes, Drew, this is me.
Okay, okay. I thought it was you. I was just telling people if people are coming to OCP, we usually plan an evening thing. And I think Vilas told me you were planning something. You were thinking you'd, or he was thinking you were planning something this year. Maybe.
Yeah, no, it's good that I probably missed that part because others are also asking. Yeah, so let's decide. Typically, there is last time I think what happened was there were some conflicts or some other events, but what day is our presentation? Some we should plan something. We should meet in that lobby or something. It's generally we can do it on the patio event. We can meet there, and then if it continues, then we can move it inside the hotel lobby, the Marriott. That
Yeah.
yeah, that works. Then that'll be good. Yeah.
Well, I guess like we just got to figure out how to like notify everyone.
Yeah. So, who all is going? Uh, we can just blast it like last time. I just sent a group email that hey, we are here. We're going to meet here. Send a picture of wherever that place was, and we can just do it that way.
Okay.
And we also have a text group. Some of the folks, but I don't think it's that big. Not everyone is there. So, right.
Yeah.
So yeah, definitely. That's the most fun part of being there to meet everyone.
It is. Well, and just to and all the hallway conversations are nice. They really get, I think we've made a lot of progress in the past.
Oh yeah, it makes it easy to work with each other, to know each other.
So then, we were going to spend half, like Yogesh and I had talked, we thought we'd spend about half the time, uh, or at least some part of the time doing OCP planning, and then some of it going through the memory scenario that I started. And so, I don't know, Yogesh, what else we want to cover. I'm pasting something beautiful into the chat, and that is a link to our document on the contributions database. So we are now official.
Yep.
I think everyone knows it, but just in case you didn't, we've officially published our doc.
That's great to
Yeah.
see it.
Yeah, this is great. It's the same document you sent out a couple of weeks ago, right?
It is it's the requirements doc, and I think part of what we need to do. So like what I'd like to do is go through some scenarios on. I just remember at Google, a guy came to me and heard that I was trying to predict memory failures, looking at memory errors. He's like, "You can't do that. It's impossible. It doesn't work." And he was like adamant. And I just looked at him and said, "Oh, you were counting memory errors when you tried it, weren't you?" And he's like, "Yeah." I'm like, "That's why it didn't work." And that kind of took him off guard. But I could tell what he was thinking is that, "Oh, you can't count memory errors and predict failures." And I'm like, "No, you can't. You need to understand the failure patterns." And so the scenario I'm writing is trying to get that message out and demonstrate some of the fallacies that people have about memory errors. Like a low rate of memory errors means there's no problem, and a high rate means there's a gross problem. And it just depends on the pattern. It depends on the ECC. And so, what I'd like to do is write this, get this scenario out as educational, to get more people aligned on what we're thinking. And maybe, like Evan was saying, we need to kind of advertise the work. We can also use it to advertise, um, like things that we're doing, and get more buy-in. So that was the motive behind what I'm doing, and maybe I was thinking that, and I'm kind of going to what's next, Yogesh. I was thinking, if we can nail that and put some, like I think the memory vendors will have some documented evidence that some of what I'm saying is true. If we can, agree on the evidence and put make this really credible for folks.
Yeah.
And
Yeah, I was saying, and I think what we can also use is there are some published industry studies, like the one you had, Google.
Yeah.
And AMD published some, Intel had some about predictions. So we could maybe discuss those here too, and include the references in the document.
I think that'd be great. Yeah, and I'm happy to go grab that. And I'm just showing you a beautiful picture while we're talking. This is the contributions database, and this will scroll off eventually, but here we are. So yeah, I agree with you. And like I know Roy had done a study that he presented in this meeting, so I know it's not too secret because this is public.
Yeah.
Where where he and I had been debating how often do you need to sample memory errors to get a representative sample. And so, I think SK Hynix had done some experiments where they they pulled a certain amount. And so like bringing that back up and incorporating that into the scenario. And then, yeah, I can absolutely bring in information about I'll put a reference into the paper I did with VLOS and others at AMD when I was at Google. But if there are other references, maybe we could do that, Yogesh. We could collect some of those references at the end.
Yeah,
Uh,
but we need to look at them one more time just to make sure they're consistent with our what we. I mean, they're one referred in right context, because they're data driven, and we don't
yeah.
want to blindly put stuff in there. So yeah, they'll take a little bit of work. But before, let me take a slight tangent here. On this screen, I do not know how the logos were selected, which logos were selected. So I know some folks have asked about, in what logos were included, or maybe your logos were outdated. Uh,
Oh yeah. I mean, I think this was just, something that OCP does. So I didn't pick these logos. They kind of came up automatically. And so I think that uh, we told Alicia, and I think she fixed it. But Micron folks, is this the new logo?
Yep, Micron one looks good now, Drew. And
Okay.
that released, fairly recently. It actually released days before the global summit last year. So I scrambled to update ours before the
Okay.
global summit last year. But yeah, it doesn't surprise me that it was the old one still in there.
Okay. Well, thanks for raising it. I mean, if you all see something like that, please speak up, and we'll. But yeah, 'cause I don't know anything else to do. I mean, Alicia was the one that fixed this.
yeah, no, so that's good. Yeah, and as far as who was the contributors in the document itself, I think we had it open for months. That if you contributed, add your name. So that
Yeah.
was pretty open process. We didn't really pick and choose. So yeah.
Yeah. Whoever had their name, we just told people to put their name. So if we've left someone out, I'm very sorry. But we wasn't.
Yeah, another thing is it took a lot of work to get it through, so we're not really going to go back and do it, revise it to add name or something like that. That would be too much of effort just for that. So hopefully, I'm looking at Theo's name. That should be there for next version. Theo,
Yeah.
NVIDIA's logo should be there, right?
Mm.
Yeah. Yeah. And can you see that I'm sharing the doc right now?
Yeah, I
Or
can see it, Drew.
okay. Okay. So yeah, I mean, I guess what I would say is let's update it and get people to add their name, and that's great. Yeah, absolutely.
So we have frozen this version, or marked it done, and then now we'll work on the next one. And for that, I think the discussion needs to take place whether HBM or LPDDR, which one we want to follow first. That is something we really need inputs from all the stakeholders really, but mostly from fleet owners. What is more valuable from their perspective, or the system integrators, what is valuable?
I need to go ask. So here's the way I know what, like, officially, HBM is really hugely used, and is a big deal for AI accelerators across the board. But LP memory scares us more. Um, has more room for STC. So I'll go talk to Microsoft's memory group to get an opinion. And then, if there are others, I think I'm the only I'm representing the only hyperscaler at the moment. I don't, oh, no, here's, we have Meta. Well, you're not a hyperscaler, Meta, but your opinion is super important. And then we can ping, Meta, and I can ask Google to weigh in.
Yeah, and I don't know, Theo, you're still in official capacity or not, but I think your NVIDIA's view is going to be very, very valuable here.
Yeah,
Sure.
I'll firm that up. I probably can represent from memory, but I'll firm that up and let you know, Yogesh.
Thank you.
As far as I can see, there's nobody else involved from NVIDIA.
Okay.
Except there are sometimes silent partners, so I want to make sure that that's not the case.
Great, thank you. And I see two things here, right? One is HBM is more evolved, defined onto its second version in data centers. So we know it's probably going to be a little bit easier to work with. LP is a little bit behind in that sense of being defined or evolved in the data center ecosystem. So we can also think about what is really more doable than less. That might be one of the considerations for us to proceed.
Yeah, I think that, and and Theo, I'm terrified that there's a tendency to use LP for the performance benefit, but the SDC potential is so high. The ECC is relatively weak, so that's what
Mhm.
I'm real, like, with NVIDIA in particular. It's something that we just, like, we'd really like to hear thoughts about how we protect our data if we have a lot of LP. So anyway, that'll be a really
Yeah.
good topic. I like that you're raising it, Yogesh.
Yeah, I agree. I think it's important. I guess both are important. LP is it's the newer entrant into the data center. So I
Yeah.
think there might be a lot of questions about that. So I think that it would be good to uh, go through all that.
Well, and when I was in a previous job, we used LP, but we put actually fairly strong ECC on it. But it was kind of ugly. It was kind of, bolt on. And and so that may be, something we have to talk about is, like how do we, can we make it so that LP is reliable enough with some strange ECC scheme? I don't know.
Yeah,
Yeah.
that's the challenge there, right, Drew? There are variety of protections, not standardized. So if that is the case, especially for LP, right? If that is the case, then which ones do we pick? How do we find the common requirements? Because folks are
Yeah.
trying to improve LP in proprietary ways, right?
Right. Yeah. I think what we want to find is the requirements, like you said, Yogesh, right? We don't necessarily have to, to dream up the right ECC mechanism here, but what are reasonable requirements so that we don't have a whole lot of SDC or any SDC? I think that's probably what we want to go through.
Yeah. I agree. And that's kind of where I was going, Theo, is that, like we can't really talk about ECC schemes that are, I mean, we could talk about like the basics of enabling ECC here, but yeah, I agree with you that we can't really, but the problem is it's a JEDEC thing. And so what we would do is, talk about our requirements, and then we have to go to our JEDEC representatives with whatever we come up with. So we have to be
Right.
careful. Yeah.
We had to do the same thing for PCA, right? So
Yeah. Yeah.
yeah.
Exactly. Okay. Well, and so I think that'll be it. Is do we do? I think unless I think what I propose is we work on the scenario next, uh, kind of as a educational lead into all our work, and then we go from the scenario to HBM or LP as we scratch our heads and figure out what our priorities. So, I mean, I
Yeah,
think that's what people were saying, right? Is that controversial?
sounds
That's
good to me, Drew.
Cool. Okay. So, then maybe I should go to the scenario next. Are we ready? I'm not hearing. Then can you see what I'm sharing?
Yeah,
yeah.
Yep.
looks
Let
good.
me- It's just I have some lawn mowing going on outside, so I just want to keep muted as long as I can.
Mhm.
Oh, okay. Okay. So, I welcome people adding their name to this as they contribute. So, um, and I've talked about this scenario before, so I've added the link. I need to do there's a lot of cleanup here and a lot of fleshing things out and a lot of adding data. But I'm talking about, polling versus rate limiting versus leaky bucket and the problems with them and the desire for hardware rate limiting in the dock. And just as a reminder, um, you know, one of the things I'm trying to illustrate in this scenario. Oh, and I'll paste the link to the doc so that you all can uh, jump into it. Okay, so here's a link to this doc, and hopefully, if you can't get into it, just request access, and I'll grant it. But what I was, just as a reminder, what I was trying to show is that we're along for the ride when we're monitoring memory errors at runtime, and that we're dependent on what software wrote to memory. So if software wrote a 1 and the bit is stuck at 1, then we don't have an error. So, I think people have this magic, notion that you get a memory error, and that's enough to figure out what's broken. And but you write a 1, you don't get an error. And if software doesn't access the data, then you might just get an error once a day when the patrol scrubber hits it. But then the exact same error, if the OS writes the value that memory can't store and starts using the memory frequently, can drive the error rates through the roof. And it was the same error, the same error that you were getting one a day or maybe none a day. And, as software's use of that memory changes, the error rate can skyrocket. And so, my goal is to just illustrate that we need to look at patterns and say, where are the locations in the array? And if I have one location in the array, a memory array, that is the source of all the corrected errors, then I'm probably, with chip kill ECC, pretty likely not to crash. But if I have, an error on every rank on a channel, then I have a channel signal integrity problem, and I need to do something urgently to address the failure, the impending doom. So, that's kind of the intent behind this, and I walked through that. Um, and I'm kind of glossing over it, but I want to address some misconceptions. Like, you can't diagnose a failure from a single corrected error. You can't count errors. Uh, you don't need to capture every error. So in fact, it's not even possible, because if you have a hard memory error and you're running code in it, you will generate errors faster than the processor can take interrupts and log the error. And the only way to capture that is a logic analyzer. So you really don't need that. And Roy had some proof. And this has been my experience, is that if I get 1 error per second or a couple errors per minute, I can generally see a pattern, and that's good enough. And so I wanted to talk through that. And memory vendors in particular have suffered at some of these misconceptions. So, you know, uh, Studi or Evan, if you all have other misconceptions that, you would like to address with your customers, but like to do it indirectly through this doc, I would be glad to add them and, try to help clear up things.
Yeah, let me ask the rest of the team, Drew. I think what you have here is a really good start. Everything I can think of offhand, you pretty much captured here.
Okay.
I mean, you've been beating the drum of counting errors and things like the need to capture every error. Yeah, you have a really good start here. We'll see if there's
Okay.
anything we want to add.
That would be great. I mean, I feel like you all know a lot of the pain points because you get a lot of parts back that don't have faults.
Yep.
And the other thing is, and another thing we may want to add is, hey, if you send data back with the DIM about where the failures were, your odds of finding your odds of, as a memory vendor, finding the fault go way up. At least that's
Yeah.
been my experience. Is if we give you clues at what's wrong with the part, it makes it a whole lot easier to find the problem.
Yeah.
But I don't know if we need to address that here. But like, please speak up. Please tell us. Okay. And then and so then I have this scenario. I just was bullet lists, and what I'd like to do is put some pictures of memory in and show, like part of a row fails in memory. So I'd like to show, hey, here are rows and columns, and this little bit failed on one DRAM, but we have chip kill ECC, so the odds of a stuck bit causing a crash are infinitesimally small, and maybe a row failure is more serious. But I walk through that, and and so I say, well, at first there's no error because the ECC is correct. And then allocate the OS, writes a value with a 1 to a stuck 0. And so now I get a single bit error. It's corrected inside DDR5 when we get ECS errors. And ECS is a little bit problematic too, and that's something I would like to address at some point. Is and my wild proposal here is for ECS, what I'd like to propose is that we have mode registers that capture an error, and we can pull the mode registers periodically to get error logs out of the memory that say where in the array the error occurred and which bit flipped. And what that would allow us to do is, some of the analysis that we could do on DDR4 but can't on DDR5. But anyway, ECS hides errors, and the threshold, it can't be is 4 or higher, so it's invisible. Now we write another 1 to that same cache line that had an error in it. So now we get a 2-bit error, and we start seeing it, and but we're only seeing it once every 24 hours because software is not using the row. It's just they wrote some data and just left it. And so Leaky Bucket won't see these because the rate's too low. But we do have a problem. But it's really hard to see because it's infrequently read. And then
Drew, sorry, just a quick thing. Should we add a references section because the threshold cannot be set lower than 4 comes from JEDEC. Maybe either we can just.
Yeah, 100% agree. In fact, if you have the document open,
Yeah.
mind putting a reference section at the end, and
Yeah.
I'll put one of us can put a link.
Yeah, I'll do that.
And we can just
Great.
put a link to the JEDEC spec, and if if someone has access to, if they have JEDEC membership, then they can see it. If they don't, they can go by the spec.
Yeah, sounds great.
Sounds good. Thank you. Thank you for raising that. And so now we have a second bit, and we see it, but we don't see it often. And so it's kind of, it's like polling and rate limiting will see it. Leaky bucket will hide it. And we'll get error logs, and we can analyze it, but all we're going to see is one cache line address. Now it starts reading the failed row, and polling sees it. Leaky bucket may or may not see it. We can rate limit, but we still only see one cache line. Now we start reading the row frequently, and we're going to have a lot of errors. And the demand scrubs might impact performance, interrupts might impact performance, but the only thing that changed was software behavior. There was no change in the actual failure mode. And then we write to another cache line in the failed row that's used frequently, and now we have the errors across a row address, and we can infer that the fault was a row and do a post-package repair. But that, if this progression happened, there's no telling when we, would be able to tell that the row failed. And so that's what I'm showing is that, we're dependent on what software does. And we need time series analysis. And so that's a high level overview, and I welcome help fleshing that out. I don't want to walk through the details again here, but what I'd like to do is I'd like to clean this up, make it a little bit clearer. Maybe we could have heading sections and call out the changes in each progression of the scenario a little bit more clearly, and a picture of the failure and what's failed versus what we've been able to log. Like we could have a picture and say, okay, all these bits failed. The only bit we can see right now that's failed is this. And then I think, as Yogesh was saying, if we can provide evidence, and I can use my the document I did with AMD to call out that row errors are actually more likely than channel errors. We can talk about the likelihood of different failure modes, and that we have to be careful, because if I see one bit failed or a handful of bits failed, it's likely an isolated error until I can't really conclude that it's a broader error till I actually see error somewhere else, because most memory errors are small. So anyway, and Evan, if you all have analysis goals here, please add them to the doc. Like if you want to guide your customers to think of memory errors a certain way, I think that you as a memory supplier can treat this as an opportunity to educate your customers without telling them directly they're wrong. And you can just point them to this, and I can help you tell them that they're wrong. But you know what I'm saying?
Yeah, yeah, it's helpful to have documentation like that, Drew.
Yeah. And it's helpful to have a team effort where it's not just
Yep.
you saying it, but it's like an industry group that agreed to this, and that'll make it not Micron. It'll be all of us. So anyway, oh, and and as usual, meet us behind the scenes fixing problems. Thank you. I love it. So I will. Oh, go ahead.
This will be only scenario in this document, or we want to have a document containing multiple scenarios?
Well, I was calling this memory corrected errors.
Right, I saw that, but yeah, that's the scope for this particular document. Okay.
Yeah, and how do you analyze corrected errors? And you know, because some corrected errors are benign, some are bad, some are hidden, some are exposed. So, and then I was imagining, you know, if we wanted to put other scenarios in the doc, I don't care. If we want to have other docs for scenarios, you know, I don't know. I was just thinking memory corrected errors here, though.
Okay. No, that's fair. Thank you.
And like, you know, memory vendors, if you all have another way you want to break the scenarios up, we can split the document, or we can have one big document with all the scenarios. It really, you know, like I said, I don't care. We just really need to spread the knowledge around a little bit more effectively, so that I don't have people, you know, it's shocking to me that this guy at Google was so adamant that we couldn't do what we were doing. And they just hadn't thought to look at the pattern. You know, that was pretty shocking to me. It seemed pretty obvious. And when I explained it to him, he kind of was like, he said, "Oh, really? Oh, that makes sense." You know. Um, and you know, the other thing that I'm not quite sure of, Yogesh, is, and I know you're not at Intel, and you and Theo aren't at Intel anymore. But what would the like what can we say about I guess we can point people to the requirements doc, and ask people to consider logging that. But like, can we point them back to AMD and Intel best practices somehow for the logging? Because like if you think about this, the average user of a server doesn't have much of a BIOS team. And so Mita, I don't know, you know, do you have BIOS folks at Pure Storage? I mean, we do at Microsoft, and Google had BIOS people, but I don't, and HP did. I guess you all would too, I would assume.
So we we use a contract manufacturer. We do have BIOS expertise, but we farm it out to a contract manufacturer.
Okay. Because like, you see what I'm saying? I'm not sure that we always have BIOS things that we I'm not sure every reader of this. Well, okay, let me put it this way. I am sure that some readers of this document will not have BIOS background or BIOS expertise, and so we need to be able to point them to Intel or AMD's solutions for helping them collect the data.
So, sorry, Nita is saying something.
I was gonna ask, like, should we put also a reference maybe maybe you already said that, Drew, to the docs that we just published, the FMFM, and
Yeah,
yeah, I think, yeah.
I've got it. I'm a buffer, so there we go. Yeah.
So
Oh,
we can we should
go ahead, Yogesh. I'm sorry.
ask folks like Vilas and Shivada, but there are, and Theo knows because he was part of authoring, there are publicly released documents, especially with the fleet operators, CSPs, about what memory error mitigations are available on their platforms built around these CPUs. So those might be useful references.
Okay. Yeah.
Yeah, I agree. I think that would be, those would be good additions. I'm sure AMD has something similar, yeah.
Okay. Yeah. So hopefully that's okay. We can just add something, and then we can. What I'll do is you think I should point Shibata? Let's see. Okay. And
I think the last would be fine. Yeah.
Yeah. Yeah, but you see what I'm trying to do is like give people useful educational material, but then give them the references to go implement it. Oh, cool. Yeah, that's actually, I see the document you pasted. Yeah, hopefully Intel doesn't mind us referencing that. That is good.
I still want to have someone from Intel approve it. I give you the link, but I think we should still have. I mean, this is public. We can always vote it, but still good idea.
Yeah.
Tell Shubhada, hey, we are adding this. Is there anything else there that we should look at?
Okay, sounds great.
Something newer, which we don't want to ignore.
Thank you. And if there are other references, like Micron and Samsung or SK Hynix.
Yeah, actually, even Micron has some good white papers, right? Maybe those may be useful too. Right. I don't know if Ivan heard me, but I was just
Yeah, I'll see what I can dig up, Yogesh.
And then the other thing that I was so what I would like to do is when I do the walkthrough of the scenario, I'd like to have a picture of a memory array, kind of a I don't know, like just say, here are the bits that fail and like a diagram of a DIM and say, okay, with chip kill ECC, I can correct one error, or I can correct errors from any part. So like pictures of diagrams of that. Do you all have diagrams we could use, or do I need to? Like at Google, what I did is I just drew a picture of a DIM in Google Docs. It was horrible, like with little rectangles, and it was a drawing I could paste in, and then I'd start editing. I'd like put an X over the bad DRAM, or I'd talk about how the DQs, map to pins on the card edge or whatever. But if you have some sort of drawing of a DIM and drawing of a memory array that we could leverage, that'd be amazing.
yeah. I think I can probably create one to show the you looking at you want to highlight the failure modes, right?
Yeah, and I'd like to emphasize that, like explain that, okay, look, ECC can, like if you start with a baseline understanding of, hey, ECC can correct a fair number of errors, and here's roughly its capability. Then, we say, okay, now we're going to drill into one chip and a failure, because the odds of two chips failing are pretty small at the same time. So let's drill into an error on one chip. And when we go through this scenario, because a corrected error, pretty much by definition, is a single chip, unless something's horribly wrong and you're aliasing. But if you're aliasing that bad, you're probably going to get an uncorrected error interwoven in there anyway. So, my assumption here is we have a failure on a single part on a DIM. And so I'd like to have a picture of a DIM and say one of these parts is having an error, and then drill like zoom in on that part and say this part has rows and columns, and have a failure in one row. And so I don't want to talk about any thing really sophisticated or proprietary. It's just a very public view of it.
Yeah.
So okay, I mean, if you're willing to draw drawings, Yogesh, that's great. But I was just wondering if the memory vendors had some stock drawings we could.
They might already have some ready-made.
Yeah, I think we for sure have something we can at least adapt a little bit and use for that, Drew. I don't know if we have exactly what you're looking for, but we have a lot of the different levels of that. I think we could contribute that. Like we certainly have we certainly don't need to redraw a picture of a DIM. We've got those.
Yes, that's where I was going for, is
Yeah.
that clearly you've got a diagram of a DEM.
Yeah.
You know,
Yeah. I don't know if I can paste pictures into the um, chat here. I haven't actually tried that before. Nope.
or you can paste them in the doc.
Well, Micron won't let me. Yeah, I can
Oh,
just paste one into the doc. Just give kind of an example of what we have, just kind of as a baseline. We've got, I know we have kind of a dim level picture, and then we can talk about kind of how that maps to module DQs, and then from there, kind of the normal picture we've used has been sort of like a single burst type resolution per DQ burst bit map. So I don't know if that's what you're looking for kind of next level, but usually when we're talking about an individual DRAM, that's the kind of mapping we've used, just kind of how the system might see this. But
yeah,
we can start there and figure out how we want to adapt those.
yeah, that would be wonderful. Yeah, if we could, I'll take any diagrams I can get from any company, nothing proprietary. We're not trying to be proprietary, just very open-ended and educational. So thank you. That'd be awesome.
Yeah, and I mean, nothing I'm talking about here is proprietary.
Yeah.
It's all kind of, hey, DRAM can have errors. This is how they can present.
That's perfect. Yeah.
Yeah.
And then the other thing I was talking to folks, I think, Mita and I were talking, and Mita, I don't mean to put words in your mouth, but you and I were talking about bounded fault. And so, bounded fault may play into this, and it wouldn't hurt to, mention bounded fault as well in the
I
scenario.
was actually going to ask if we were, but I didn't because I thought in case it adds too much complexity, but bounded faults and then how the hierarchy, architectural hierarchy of the DRAM kind of plays a part into us doing fault isolation more effectively, right?
Yeah. Yeah, I think that would be, and like some of the exact way that the elements of the array are mapped to DQs may be proprietary, but we can just say there is a mapping because everyone knows that the bits in the memory find their ways to the pins. So we can just be non-prescriptive of how that's shifted out, and or non-descriptive. We can just say, it happens.
Yeah,
Uh,
we could just point then to the DFSA, the DRAM fault analyzer, as part of the solution,
mhm.
because then that just gets encapsulated in that uh, uh, black box, right, for us.
Yeah, well, and the beauty is that and the thing that's really cool is bounded fault kind of constrain that mapping some. So, and that's beautiful because now we can make more assumptions in ECC about how things fail. So that's one of the glorious things about bounded fault is that by having very consistent assumptions about how things fail, then you design your ECC accordingly, and it becomes more effective. So, but we don't need to get into the gory details there, but I think if we had like an overview of ECC capabilities, uh, a very rough one, because we need to, like how our error is corrected. That's really what I'm going for. And not in any detail, but just like ECC can detect a flip bit, and sometimes it corrects it, and sometimes it doesn't. That's nothing super sophisticated. But then say, hey, with bounded fault 10x4 DDR5, you should be able to correct parts from any DRAM. Or I'm sorry, correct errors from any DRAM. And then we'll jump into, okay, now that we're talking about corrected errors, here's what might play out. Great. Well, so if it's okay, so if you all are tracking with, the goal of what we're doing, I did this with poison. I have the poison document I contributed, And I'm already seeing huge benefits to this, like inside Microsoft. I've been sharing the doc, and it's simplified so many conversations to have a document that describes how it works and gets people on the same page. And I just can't help but think this will do the same. So thank you. If you know, and if you have concerns with what we're doing, tell me. We'll try to shy away from anything too proprietary or anything sensitive. But if we can educate, you know, all of our partners and customers on this, I think the payoff would be huge.
This is really good stuff.
Okay. Well, with that, I'm gonna, that's about, I wouldn't walk through it in too much detail, Yogesh, and I was thinking that maybe what we can do in 2 weeks is come back and I'll try to like crispen up the scenarios a little bit better and separate them with headings. And if we can paste a few drawings in the meantime, if folks want to add references or try clarifying things, let's just build this. And I think, hopefully we can get it done in, like a month or so. And then what I'd like to do is contribute it.
Yeah, I think, realistically, after this meeting, we'll probably we'll have a little bit of fatigue from Global Summit, and we'll see if we really meet in 2 weeks. But
oh, yeah, I hadn't thought of that.
so yeah, maybe a week after summit we'll cancel, because we all have to, a lot of us have to travel and all that, and takes away a lot of time from those who have day jobs. So yeah, but I think that's a good plan. Timelines may vary, but yeah. Good
Yeah.
plan.
But at least certainly by the end of the year we should have this published, I hope. And if it's not too controversial, and then we can jump into DDR, LP or HBM, depending on the need. Cool.
Yeah,
Okay.
sounds great, Drew.
Okay. And like I said, if you have any concerns, or if there's anything sensitive that you want to just tell me to shy away from, you can even tell me privately, and I will quietly shy away from it. But hopefully this is good with everyone.
Sounds good.
Thank you so much.
Thanks, Drew.
Yeah, appreciate the
Thanks,
partnership.
everybody.
Thanks.
We'll
See some
see you
of you
next week
next
in
week.
San
Yeah.
Jose. Yeah,
Sounds good. Looking forward to
looking
it.
forward to it.
Yeah.
Yeah, it'll be great. See ya.
Okay, see ya.
Bye.
Bye.